Hello friends, in today's lecture I am going to talk on one of the very useful library of Python, that is SciPy. I am going to discuss the theoretical part of this library so that it will be convenient for you to learn SciPy before jumping to the practical part. So let's get started. SciPy stands for Scientific Python and is pronounced as SciPy as already I am pronouncing. SciPy is a free and open source Python library and is used particularly for scientific computing and technical computing. So let's first talk about what is scientific computing. Scientific computing is the collection of tools, techniques and theories required to solve on a computer mathematical models of problems in science and engineering. Or in easy terms, you can say that scientific programming deals with solving scientific or mathematical problems with the help of computers. Alright, as you know that mathematics deals with a huge number of concepts that are very important, but at the same time they are complex and time consuming. However, Python provides the full-fledged SciPy library that resolves this issue for us. The basic scientific operations are like arrays, matrices, integration, differential equations or statistics and many more like this. Like problems related to the arrays and matrices can be resolved with the help of NumPy, but as far as concerned to the integration, differential equations, stats and like these problems, we require SciPy. So SciPy contains modules for optimization, linear algebra, integration, interpolation, special functions, FFT, signal and image processing, ODE solvers and other tasks that are common in science and engineering. SciPy allows users to manipulate the data and visualize the data using a wide range of high-level Python commands. In Python, SciPy package is the most used scientific library, only second to the GNU Scientific Library for C and C++ or MATLAB. GNU Scientific Library is also known as GSL and it is a software library for numerical computations in applied mathematics and in science. This library, that is SciPy, is easy to use and understand as well as fast computational power. This library can operate on an array of NumPy library. SciPy module in Python is a fully featured version of linear algebra, while NumPy contains only a few features. That's why we require SciPy. Most new data science features are now available in SciPy rather than in NumPy. And the important thing is that SciPy is built on the Python NumPy extension. So if you import SciPy, then there is no need to import NumPy. And the creator of the SciPy is same, that is the creator of NumPy, that is Travis Oliphant. The core SciPy library are NumPy, SciPy, Matplotlib, IPython, SymPy and Pandas. SciPy is predominantly written in Python, but a few segments are written in C. Now let's focus on its features. The first important feature is fundamental algorithms. SciPy provides algorithms for optimization, integration, interpolation, differential equations, statistics and many other classes of the problems. The second feature is it is broadly applicable. The algorithms and data structures provided by SciPy are broadly applicable across domains. Next feature is foundational. It extends NumPy, providing additional tools for array computing and provides specialized data structures such as sparse matrices and k-dimensional trees. Next is performant. SciPy wraps high optimized implementations written in low-level languages like Fortran, C and C++. So you can enjoy the flexibility of Python with the speed of the compiled code. Next feature is it is easy to use. SciPy's high-level syntax makes it accessible and productive for programmers from any background or experience level. It is an open source project like NumPy and you can use it freely. It is distributed under a liberal BSD license and is developed and maintained publicly on GitHub by a vibrant, responsive and diverse community. Now here is the table showing some important points regarding to the development of SciPy library. So that's all we have with the theoretical part of the SciPy. I hope you have learned. That's all we have today. Thank you.